Hi friends, I'm Anuradha, and as part of this lecture, we'll be learning about Docker Network. This lecture is also part of YouTube series Docker for Testers. So in case you want to start from scratch and learn Docker, you can go ahead and begin from lecture 1. Different containers running on one single machine or on across different machines need to talk to each other for achieving complete application or complete testing solution for that matter. For example, in case of distributed performance testing, master needs to talk to slave. Similarly, in test automation, in case of parallel testing, master machine may need to talk to different machines where test automation suite is running. Let's go back to our AWS EC2 instance, which we have been using throughout this lecture, and let's see how Docker network work on single machine and how containers on single machine talk to each other. So I'm on AWS EC2 instance and let's see if any container is running. So there is no container present on this machine, neither running nor stopped. Let's see the networks present on this machine. And that we can do with the help of Docker network ls command. So we see there are by default 3 networks available on machine: bridge, host, and none. When we run container without specifying any network option, by default container gets connected to this bridge network. So bridge is very important network. Containers talk to each other, to the external network, to the host machine with the help of bridge network. So let's park this network for some time. We'll talk about it in some time, and let's talk about the other 2 networks, host and none. To explicitly connect these networks to container, we have to specify network option while running container. So let's talk about none option. When we run container with network as none, it gets no IP address, it gets no port, and it is in completely isolated mode. So when do we use none? Generally, when we have to run any batch job. When we run any container with network host, it gets IP address of host itself and it gets port of the machine on which it is running. So you don't have to do port binding, which we learned in one of our earlier lectures, to connect localhost port to container port. So I'm on my host machine. So there is no container on running or stopped on this machine for now. Let me run one container in detached mode, and here I'll connect it to host network by giving network option. I'll use image Grafana, which we have been using in our lectures. Okay, so I'll run this container and this is container ID. Let me access this container. We can do that with execute command and container ID and sh. So we are inside container. Let's check the IP address of this container. Okay, now let's exit out of this container and let's check the IP address of host machine. Do you see? These container configuration is exactly similar to host machine configuration. Its interface, its IP, everything. So let's access this container. So Grafana in general runs on 3000 port and we can access Grafana through HTTP. So let's go to HTTP port and let's access this through public IP. We have not done any port binding, and let's see if we are able to access this container without port binding. And yes, we are able to access this container without any port binding because the port which this container is using is actually the host port and don't need any port binding. So this is how container runs with network host. Let's go to our final network, which is bridge network, and which is very important network, and let's talk more about it. So currently I have removed all the container instances, and I hope nothing is running as of now. Okay, so there is nothing running. Okay, and let's talk about bridge network. And before we run any container, let's inspect this network. And to inspect any network, we have to give command docker network inspect and network name. Okay, and let's run this. So if you see, there is no container currently associated with this network. Now let's run container and see what happens. So I'll run container. Let me clear it. I'll run container. I'll run it in detached mode, and I'll give Grafana. Okay, and here you go. Let's again inspect network, and now you see there is this container getting associated with it. I have not named the container. Let's check. So this is inspiring something, and it is attached to this bridge network. Now let's run one more container. Let me name container this time Grafana 2. Okay, and let me inspect network again. You see, the another container which I ran also gets associated to this bridge network. Let's note down the internal IP address of these two containers, and also observe that these containers get associated with the bridge network within this subnet and gets the IP address accordingly. So let me duplicate session and open one more terminal. Okay, and let me connect to one of the container. I'll maximize this for now, and let me see the ID over here, and I'll connect to one of the container docker ps. Okay, so to connect I have to give docker execute it u0 container id and sh. So here I am on this container. Okay, let me again restore it to the size, and let me ping the host machine from this container 172.31.45.92. I need to restart this session again somehow. EC2 user. Let me clear it. Let me check the IP address. IP80R, and so this is the IP address of this machine, right? So I'll ping to this IP address. So I'm able to ping host machine from this container. Okay, let me connect to the other container. Let me ping other container from this container, and let me just open, let me just inspect bridge network again. Inspect bridge. Which network I have opened? I guess I have opened, I have connected to 19. That is the first one. Okay, so I'll ping the second one from here. Second one is 172.17.0.3. Okay, let's try to ping the other container, and we are able to ping other container from this container. Great. Let me try one more thing from here. Ping, and let me give the name of container. It says bad address Grafana 2. So we are not able to ping container using container name, but we are able to ping, or we are able to communicate using the internal IP address of this container. So effectively, with this default bridge network, what we are able to do, what containers are able to do, they are able to talk to each other using IP address. Then they are able to talk to host machine as well, right? what they are not able to do, they are not able to talk using using container name. So this was default bridge network to which containers get attached when they are run without any network option, and we saw that they can talk to each other and host machine as well. We can also create user defined bridge network, and let's see how and how it is better than default bridge network. For that we have to give command docker network create and the network name. So I'll say my underscore bridge one, for example. Okay, and let's see docker network ls again to list down the networks available now. So my network is available and it is of type bridge. Okay, now what I will do, I will run my container. Let me stop the other two containers. I'll remove them forcefully. We have seen these commands in our previous lectures also. Docker ps minus a minus q. Okay, so our containers are removed. Now let me run two new containers. Okay, and before that let me inspect my network, inspect and network name. Alright, so there is no container attached to it right now, and there is this subnet associated with this 172.20.0.0. Okay, and let's run new container now. Let me duplicate one more session. Okay, let me run container docker run, and this time I'll give network option because I want to connect my container to some different network, which is user defined bridge network. Okay, bridge 1 and again Grafana. So this is my container running. I forgot to give it in detached mode, so I'll duplicate one more session. Okay, and so this container is running docker ps and its name is some recursing Hamilton, and let me inspect my bridge, and you see there's this container this container is attached to this bridge and it gets this IP address within this subnet. Now let's run one more container. Docker run network equal to my underscore bridge 1, and I'll associate name with this equal to my Grafana. Okay, and let me give Grafana image as well. Okay, it's running. Again I missed -d command, so I'll duplicate one more session. So let's see now docker ps. I have two containers running now, and let me inspect my bridge again, and it has got the second container attached to it. Let me access this container and then we will talk further. And to access this container, I'll give command docker execute -it. I forgot to tell you why I'm giving u0. So it is default UID of root user, and sometimes if we don't give, we get ping permission denied error. So it is always good to give this UID while accessing container. So I'm accessing container with UID 0, and I'll give container ID as well. I'll choose first container and then I'll give sh. Okay, so I'm on this container, and let me ping host machine 172.31.45.92. okay, and of course we are able to access this host machine. We are able to talk to this machine, and let me connect to my second container from this using IP address 172.20.0.3. Okay, and I'm able to ping this. So far so good. And then let me try one more thing. Let me give container name here to which I want to talk. My Grafana 2. Oh, my Grafana. Okay, so I'm able to ping using container name as well when I'm connecting my container to my user defined bridge network, and this was not possible in default bridge network, right? And what else is that not any other container can access this container. Only containers which are connected to this user defined network can talk to each other, while in case of default bridge network, any container up and running can talk to each other. So this is a kind of security issue, right? So when we are building a solution uh, and we are running containers which need to talk to each other, we need to create a network for communication purpose. And yes, we need to provide port binding over here so that in case we want to access this HOO container from outer world. Okay, and we have already seen why and how in our lecture for port binding. So what we have seen so far, we have seen network commands. We have not seen network remove command. So in case we want to remove any network which we have created, we can use network rm command. And in case container is already running and we have not connected it to any network, we can use network connect disconnect. And if we want to remove unused network, we can use network prune command. Okay, so you can try this at your end. And we saw just now that default bridge network and user defined bridge network are different, and user defined bridge network is superior to default bridge network, and this is the recommended one when you go for creating your test solution on single host machine. I hope this lecture was useful to you. Let's proceed to next lecture. Friends, I hope I was able to help you through this lecture. Don't forget to subscribe my channel to stay tuned and have more such videos, and don't forget to visit my website qamilestone.com, which talks about more such YouTube series, wonderful posts, and my Udemy courses. Thanks for now.